So this is said to be law of equipartition of energies. Is it clear? Can I go ahead with monatomic, diatomic, and polyatomic?
Yes, sir.
Okay. So now, in that I am going with specific heat capacity. So what we have done until now? Can you tell? Can anyone say what we have done until now? What are the topics we have done until now?
Pressure exerted in a cubic box.
We started with postulates. After that, we went with gas laws. And after that, we did ideal gas equation. Then we did three derivations. What are they? Pressure exerted by the gases. So P is equal to 1 by 3 m n p square bar. We did this derivation. The next one we did kinetic interpretation of temperature. Okay, kinetic interpretation of temperature. And the next one we did is law of equipartition of energies. Is it not? Law of equipartition of energy. These are the things what we did until now. Now we will go ahead with specific heat capacity. Very, very important if you are appearing for NEET or JEE. Okay, definitely one question will come from here. This part. Okay, so so here we have specific heat capacity. Specific heat capacity. In that we have monoatomic. Monoatomic. What can you give me example for monoatomic? Anyone? Monoatomic is the atom is itself a molecule. Yeah. Can I take this one? Helium, neon, argon. They are all you know zero group elements or inert gases. Okay. Now, so here for monatomic gases, only one molecule, the molecule and atom is the same. So the temperature, the average temperature is T is equal to 3 by 2. The average energy of the molecule is 3 by 2 kBT. This is already we know. Now, so here the total energy of monatomic. This is first case, monatomic. U is equal to what? 3 by 2 kBT into Na. Na is Avogadro number, 1 mole. So what is Kb into Na? That is R. R is equal to Kb into Na. Keep this in mind. So that will be equal to 3 by 2 RT. That is equation number 1. Now, so here we have Cv. What is Cv? Anyone? What is Cv? What is
Heat capacity at constant volume.
Very good, excellent. Specific heat capacity at constant volume. Okay. How much amount of energy is required to raise the temperature of substance by 1 degree centigrade at constant volume when we are not changing the volume, when the volume is fixed? Cv is equal to du by dt, rate of change. That is, instead of writing delta U by delta T, we are writing du by dt. That is equal to again 3 by 2 RT. Now, we also know that Cp minus Cv is equal to what?
R.
Very good. What is this equation known as? What is this equation known as?
Layers.
Mayer's formula. Mayer's formula. Okay. So now, from this, because I have Cv, but I don't have Cp. So,
So Cv equals to 3 by 2 R? Like 3 will not do?
No. See, what is this Cv? What is this definition of Cv? How much amount of energy is required to raise the temperature of the substance by 1 degree centigrade at constant volume? Means how much amount of energy? That is delta U by delta T, right?
Yes.
The delta U by delta T, that is nothing but 3 by 2 3 by 2 R into D. So yeah, I have to differentiate this.
Yeah,
Sorry.
differentiate, yeah.
Yeah, I have to differentiate d by dt. So in that d by dt, so that will become what? 3 by 2 R, because dt by dt is equal to 1. Okay, 3 by 2 R. So Cp minus 3 by 2 R is equal to R. Simplify this one. Cp equal to R plus 3 by 2 R. So Cp is equal to 5 by 2 R. Okay, we got Cp is equal to 5 by 2 R and Cv is equal to this one. But what is gamma? Gamma is equal to Cp by Cv, right? What is Cp? 5 by 2 R. What is Cv? 3 by 2 R. This R and R will go away. This and this will go away. Answer is 5 by 3. 5 by 3 means 1 point something. 6 up.
1.666.
6, no. 3, yeah, 1.6 around. Something like that. Okay, the gamma value. This is important. For monoatomic molecules, it is somewhere around 1.6 gamma value. They won't give in the books. Whenever they give the numericals, they are not giving this value. Once again, the energy is equal to how much? 3 by 2 kBT. The total energy U is equal to 3 by 2 kBT into Na. Na is Avogadro number. Kb into Na is equal to R. Cv is specific heat capacity at constant volume is equal to what? Du by dt. D by dt of what? Energy is what? 3 by 2 RT. So 3 by 2 R into dt by dt will become, this I'll take capital T better to avoid confusion. Okay. dt by dt, capital T. T is temperature. So differentiating with the same term will become 1. So we, from the Mayer's formula, Cp minus Cv is equal to R. I don't have Cp. So just substitute this R here, Cv value, and bring this fellow on the other end. We get this one. Gamma is equal to Cp by Cv. Cross multiply this one. We get 5 by 3 is equal to 1 by 6. Gamma is equal to 1 by 6. Is it clear, all of you?
Yes, sir.
Okay.
So,
So we'll go with diatomic. Okay. And diatomic molecules. Now, in diatomic molecules, again, we have two cases, man. Homo, hetero.
Sir, homo and head.
Homo means same, N2O2. Hetero means HCl, NaCl,
HCl, H2SO4,
any.
and H.
No, not H2SO4. Only two atoms make a molecule.
Okay, sir.
Clear? Again, in this, they have brought one more situation. Rigid diatomic, non-rigid diatomic. Rigid and non-rigid. Why? What happens in rigid and non-rigid? In rigid, oh, we don't have vibrational. Okay, EV will be equal to 0. But in non-rigid, EV will not be equal to 0. You understood now? It's like a spring. Yes, I will give. Don't worry. Don't worry. Maybe tomorrow morning. Okay. Let me finish off this. I will give tomorrow. Okay. I'll just don't worry. In the all the important questions, as I told. Okay, for all the topics or from both the books. Okay. Definitely, I will share some important questions, like some important questions or some important topics. What we have to focus. Okay, for the examination. So EV is equal to not equal to 0, non-rigid. It's like a spring. Okay. So therefore, what will happen? U is equal to we have. Okay. So first of all, we will see in diatomic what will happen. There will be three translational and two rotational. Three translational and two rotational degrees of freedom. Okay. Degrees of freedom. Three translation and two rotational degrees of freedom. So what we have the energy total how many? 5. 5 by 2 kBT into Na. So that will become 5 by 2 RT. It will be equation number 1. Now Cv For rigid molecules, I'm speaking about only rigid. Equal to what? 5 by 2. So actually the formula is what? Delta U by delta T, or du by dt, which will be equal to d by dt of 5 by 2 R into T. So that will become Cv is equal to 5 by 2 R. And what is Cp? Cp minus Cv equal to R. Cp minus 5 by 2 R equal to R implies Cp equal to 7 by 2 R. Cp is equal to 7 by 2 R. Now we have gamma. Gamma equal to Cp by Cv. It is 7 by 2 R, 5 by 2 R. This and this will go away. The answer is 7 by 5. Now, U is equal to, the energy is equal to, we can write here. So this is the value. What will be 7 by 5? How much it will be? 1.4.
1.4.
Yeah. This is, so remember this one. For diatomic rigid, the value is 1.4. Keep this in the mind. This is important value. Once again, in diatomic, we have homohydro. In that again, rigid, non-rigid. He's speaking in terms of rigid, non-rigid. We are going in rigid, vibration will not be there. In non-rigid, vibration will be there. So as of now, in rigid, we have translation and two rotational. No vibration as of now. So 5 by 2 kV, 5 degrees of freedom. So 5 by 2, 5 into half kVt. So that will become 5 by 2 into Nn, Avogadro number means 1 mole. So 5 by 2 RT. Cv for rigid is du by dt, d by dt of 5 by 2 RT. So 5 by 2 R is the formula. Cp minus Cv is equal to R. Cp minus 5 by 2 R is equal to R. So simplify this one. 7 by 2 R. So gamma is equal to Cp by Cv. Cut it, you will get 7 by 5 is 1.4. Is it clear? So gamma is 1.4 for diatomic rigid molecules. Okay, now here, if we are going with vibration also, non-rigid. Okay, if you are going with non-rigid. In non-rigid, what will happen? 3 translational, 2 rotational, and 2 vibrational. Total how many? 9 degrees of freedom. Is it clear? Total it will be 9 degrees of freedom. So in that case, Cv will be equal to 9 by 2 RT, and or we can write 9 by 2 R, no T, 9 by 2 R, and Cp is, yeah, how many? 9, 2, sorry, not 9, 3, 7, sorry, 7. So Cp will become 9 by 2 R. So divide, gamma is equal to Cp by Cv, which will be equal to 9 by 2 R divided by 7 by 2 R. This and this will go away. This and this will go away. 9 by 7. What is 9 by 7 value?
0.2.
No, 1 point.
P. Yeah, around 1.3.
Not, is it 3 or 1.2?
It's
Or
1.2,
1.4?
but
717. 717, and then 20 is left. 7 2 is 14.
1.28.
So
Yeah,
1.2, so
1.28.
1.28.
1.28, something else. Okay. So now gamma equal to 1.28 for what? For diatomic non-rigid. Is it clear? Remember these values. For diatomic rigid, this is the value. For diatomic non-rigid, this is the value. Next case is polyatomic gases. Okay. For polyatomic, we don't know. We can't define. We can only define, for polyatomic, we can only define the translation. The degrees of freedom we can't define. Okay. 3 translation, 3 rotational we can define. That's it. Now, Is this clear, all of you?
Yes, sir.
Yeah, okay. Now we'll go with polyatomic gases. Polyatomic gas. Okay. In polyatomic gases, what we have now? We have 3 translation, 3 rotational, and F vibrational. We don't know how many vibration, because suppose if I am taking polyatomic example is like a ammonia gas. Ammonia, no? Yeah, ammonia. NH3. It will be something like this. Is it correct? Is it correct? Chemistry people. Is
Yes,
ammonia
sir.
correct? Huh? Okay.
Yes,
Is it a
sir.
planar? Yeah. Okay.
Yes.
Perfect. So here what happens is the molecules will vibrate like this. The molecules will vibrate like, we don't know how the vibration is taking place. Okay. So there is a translation, there is rotational, and there is vibration. Rotational because one rotation here, one rotation here, and one rotation here. So 3 rotations. But how many vibrations? We no idea, because it can be 3 molecules, 3 atoms, 4 atoms, 5 atoms. No idea. So we have taken this many F degrees of freedom. So if you take the formula, U is equal to 3 by 2 kBT plus 3 by 2 for rotational kBT plus F kBT into Na. So what happens here? Cv is equal to what? 3 plus F into R. Cp is equal to 4 plus F into R. Okay, we are getting this much. So now gamma is equal to what? Cp by Cv. 4 plus F divided by 3 plus F. This is gamma value. Is it clear? Once again, there are 3 translational, 3 rotational, and F degrees of vibration. So add all these 3 plus 3 and then F degrees of freedom. Then Cv equal to this much, Cp equal to this much, divide one over the other, we get this answer. Is this clear, all of you? Yes?
Yes, sir.
So he says once again, so for mono, we'll just do a recap. For mono,
Yes, sir. Clear.
gamma value is how much? 1.67. For diatomic, rigid and rigid, non-rigid. For rigid, gamma value is how much? 1.1.4.
1.4.
And triatomic, he says that the value of gamma is 1.33. Okay, keep this in the mind. These are the standard values. It can come in MCQs also. Please note down these values. Okay. Clear, all of you?
Yes.
Okay. Sharp
Yes,
10 I
sir.
will leave. Don't worry. Only 10, 18 more minutes.
Sir,
Okay.
what does F stand for?
F is the F number of degree. We don't know how many it is. It's a variable. F is a variable. We don't know. It's like X value. Is that clear? We have taken F is a F. We don't know. Depends on the molecule. We can't fix that for every molecule. Like in diatomic, rigid, diatomic, non-rigid, there is a fixed number. But when it comes to ammonia or CH4, that is methane molecule or ethane molecule, you can take any type of molecule. When the molecules are changing, the vibrational modes will change. Is that clear? Like example, yeah, it is a good question. So here, see here, carbon dioxide. If you take, it's a linear molecule. Okay, if you see the vibration, there are 2 vibrations. See, this is one type of vibration. This is second type of vibration. There can be one more type of vibration, right? You understood? One molecule,
Yes, sir.
in this case, one molecule may be moving away and the second molecule is coming towards. This is one type situation. One type of situation, both are coming towards. One type of situation, it is coming like this and this fellow is also moving away. In one type of situation, it is moving like this. You understood? So
Yes, sir.
there are different modes. So that is the reason we have defined as F for this. Is that clear? Same
Yes,
thing
sir.
can happen in ammonia molecule or methane molecule or any other molecule. So that is the reason we say this is the way. Okay, clear, all of you? F
Sir,
degrees of.
but anyhow, sir,
Yeah, tell me, sir.
but anyhow, for triatomic molecule, it will be always two, right? Because how you show the CO2, usually two vibrations.
So how many? So how many we have taken here?
Two
Yeah, here.
vibrations.
Yeah, two vibration. If you substitute and see the value, if you substitute 2 here, how much it will be? Can I just check? 4
Six
plus 2 is 4 plus 2 is 6. 3 plus 2 is 5. 6 by 5.
vibrations. 1.2.
It's not matching. Come with 4 then, because 4, no? 1, 2, 3, 4. 4 plus 4, 8. 8 by 7.
That's one
It will be
point.
less.
Yeah. But there's only like two vibrations for each case, right?
Hmm.
So anyhow, if you take any case, there'll be only two vibrations.
Hmm.
So you can take FS2 for triatomic.
Yeah, for 2. In this case, they have taken, that is the reason we got here 1 point. The value what they have calculated is 1.33 for triatomic gases. You take F as 1 and C.
5/4.
If it is higher values, what will happen? That also check. You can do this exercise, okay? Like, you can take 1, 2, 3, 4, same way and just divide and see. And you will approach at different values, okay?
Okay, sir.
Now, next concept is the specific heat capacity of solids. Suppose there is a solid bank, like a cube, some box. These are the molecules. When you supply heat, what can be the mode here? Will there be translation? Will there be rotational? Or will there be vibration? Tell me. In a solid, these are the molecules. I supply heat. It's not
Maybe
melting.
vibration.
Why no translation? Translation is equal to 0. Rotational is equal to 0. Only vibration is not equal to 0. Is that clear? In vibration, the molecule will go like this, return back. Is it not? It will come back to and from motion. So only 2 degrees. Is that clear? Only 2 degrees. So what will happen in oscillation?
Yes, sir, clear.
In oscillation, what will happen? The average energy E is equal to 2 into half kBT. 2 into half kBT. That is equal to kBT. 2 modes of vibration. Only that is equal to 2. 2 modes of vibration. So if N is equal to what? Na. U is equal to what? 3 kBT into Na. 3 kB into Na. Which is equal to what? 3 RT. So delta Q is equal to delta U plus P delta. Delta Q is equal to delta U plus T delta, P delta. In solids, do you think volume will change? In solids. In solids, if you supply heat, not to extent that you're going to melt the solid. Like little, you're going to give some, like it is a steel rod or aluminum cube something, and you're supplying heat. You're not going to the extent that you're going to melt it. Just normal. So what will happen in solids? Change in volume will be change in volume
Zero.
will be 0. Very good. It will be equal to 0. So the whole thing will be 0. So delta Q is equal to delta U. So now C is equal to what? Specific heat capacity delta U by delta Q by delta T, which will be also equal to delta U by delta T. So only there will be, what is the formula now? C is equal to specific heat capacity of what we got? 3R. Only 3R we get. That's it. There is no CP, no CV. Only C. Okay. C is equal to 3R. Now, one more case he has given. Is this clear? Once again, we have taken a cube. In that cubical box, like maybe a aluminium or maybe steel, something, a block. We are supplying heat to this one. Not to the extent that we are going to melt it. Normal, just little heat. So temperature is, so translation modes of vibration will be zero, no rotational, only vibrational will be there. Only the molecules can vibrate towards its mean position. How many? 2. So E is equal to 2 into 1 by 2 kBT, 2 and 2 will get cancelled. N is equal to Na. So now U is equal to what? 3 kBT into Na. Okay, so that is equal to 3 RT. So now delta Q is equal to delta U plus P delta V. This is the formula from, this is what? What is this formula? And from thermodynamics. First law, second law, zeroth law. Is it first? So very good. First law of thermodynamics. Okay, when you supply heat to the system, some part will be used as internal energy and some will be in doing as a work. So delta V is equal to 0 for solid. So this delta Q will be equal to delta U. Divide. So delta U by delta T or delta Q by delta T. So that will be equal to 3R. Now specific heat capacity of water. So U is equal to how much? You have 3 times, like suppose we have 3 hydrogen atoms and 2 hydrogen atoms and in water molecule.
Sir, two hydrogen atom and one oxygen atom.
H2O, one oxygen atom. So there are 3. Okay. So we have how many here? U is equal to 3 into 3 kBT into Na. So that is equal to how much? 9 kBT into Na. But what is kB into Na? kB into Na means what is that? This whole thing. Anyone? What is kB into Na?
R.
R. Very good.
Sir,
9.
capacity of
No,
9
no.
RT, sorry.
kB into Na is R. Okay, 9 RT. So C is
Reynolds
equal to
gas.
delta Q by delta T, which is equal to delta U by delta T, which is equal to 9R. Okay. So that is why they say that specific heat capacity of water, specific heat capacity of H2O equal to how much is specific heat capacity, means how much amount of energy is required to raise the temperature of water by 1 that is 1 degree centigrade. So that is equal to 1 calorie. 1 calorie equal to how many joules? 4.18 joules. Is it clear? Is this clear, all of you? Yes? Is this clear, all of you?
Yes,
See,
sir.
so there are 2 hydrogen, 1 oxygen.
Yes, sir.
So 3 degrees of freedom into 3, because there are, you have to take 3 translational, then 3 rotational. Yeah, 2 rotational and vibrational. So total how many? 3 into 3 will become 9. So just simplify that one. We get this. Okay, 9R. Okay. So specific heat capacity, because do we use volume for this? Is it only, can we use volume CV for this? Can we use volume for this? Water. Specific CV we don't calculate. Why?
So we
Any
can.
reason? CV we don't calculate. In this also we didn't calculate CV.
Because
Why?
volume change is zero.
Ah,
Delta V is zero.
in fluids, in liquids, not gases. In liquid, unless and until it goes to the evaporation stage, man. I'm not speaking, don't go to the evaporation stage. This is the condition. If you go to the evaporation stage, then that is a different case situation. In solids also, we are not going towards melting. Normally, maybe 1 degree, 2 degree, 3 degree, not more than that. Maximum 10 till the time it won't evaporate. So that is why we did not calculate here CV. So that is why we also said delta V is 0. Is it clear? No change in the volume. Is it clear? So what is specific heat capacity of water? How much
Yes, sir,
amount of
clear.
energy is required to raise the temperature of water by 1 degree centigrade? That is equal to 1 calorie. Is it clear? 1 calorie. So
Sir.
only one topic is left here. Okay, one topic, that is mean free path. Okay, last topic of the lesson, that is mean free path. Okay, so if you look at that, I'm not going to draw the diagram. I'll just, instead of okay, I'll just let me see. Is it any doubt here? Yes, sir. Any doubt?
No, sir.
Yeah. Last topic. Maybe it is not a very lengthy also. It's just a small situation, only small. That is mean free path. In mean free path, what happens? There is a molecule or an atom. Okay, here. This is the diameter of the atom. Okay, and this molecule, now there are some other molecules in its path, but not touching it. If it touches, then it collides. Is it not? If it touches, then it collides. In the vicinity. In the vicinity, it is going straight, maybe. Now, so this is again D. Why? This to half of this one, half of this. Okay, half of, see the radius again. From here to here, this will be again diameter. The same situation here also. Okay, so if you this makes a like a cylinder now. Are you understanding? This is a molecule. When the molecule is moving, think that not it is not in a colliding situation. Collision means if this molecule will come little down, then it will collide. Like, when the cars are moving on the road in a lane, think that there are three lanes, 1, 2, 3. All the three cars are moving at the same time, but they don't collide with each other because everyone is in their own lane. So now this is first lane, second lane, third lane. So this the first lane of the first molecule, lane of the second molecule, lane of the third molecule. They are not colliding each other. Each lane of each or molecule is D. Now, what is here? What is the time of collision? Time of collision is negligible. That is equal to T, delta T. Okay. So it sweeps. So what will happen? In time delta T, the molecule will sweep a volume. How much volume it will sweep? It's like a cylinder. Is it not? It's like a cylinder. What is the volume of cylinder? What is volume of
Pi r
cylinder?
square h.
Pi r square L or pi r square H or pi r square L. So, but what is R here? We don't have diameter. R is equal to D by 2. So implies R square is equal to D square by 4. Is it not? Pi r square or something like that. So here, but in this case, we can't take that one. Why? Because this is radius, right? If you see carefully, here R is equal to D, right? Is it not? This is the like a cylinder, right? So this is the whole thing is diameter, but half of this is radius, right? So instead of taking that formula here, in the place of R, can we take D? Can we take D?
Yes, sir.
Yeah. So instead of that, we are writing pi D
Yes, sir.
square. Pi D square L. But what is L? Velocity is equal to distance by time. Distance is equal to velocity into time. So we are writing here V into delta T. But V, instead of taking only V, we are taking average velocity. Because we are not speaking about only one molecule. We are speaking about the average of all the molecules. Is that clear? So if there are n number of molecules, we write here n is equal to pi d square V into delta T. Is it clear? V into delta T. Now, so the rate of
Yes,
collision.
sir. Yes, sir, clear.
Is it clear all of you? Is this clear all of you?
Yes, sir, clear.
Yeah. So the rate of collision, the rate at which collision is taking place is equal to what? Tau. Implies tau is equal to 1 by, just divide this, 1 by n pi d square v into v. That's it. We get this formula. Okay. Mean free path is the distance, it's not the time. mean free path is the distance, that is L. L is equal to what? L is equal to root V into
V
tau,
delta t.
which is equal to 1 by n pi d square. Okay, V into tau, that is equal to n pi d square. So we can also write L is equal to 1 by root 2 into n pi d square. This is a more exact value. More exact value. Okay, more exact value.
Sir, what is
Says
N
that
here?
n is the number of atoms or number of molecules. Okay, small n is number of gas
Okay, sir.
molecules present in that chamber or in that vicinity. Okay. Now, for normal temperature, okay, at STP or at STP, at standard temperature and pressure, the value is equal to how much? Is 485 meter per second. Just remember this value. Anyways, so just I will do a quick recap. Is it clear, all of you? Is this clear?
Yes, sir.
Okay, quick recap I will do. Tomorrow, same time you have to join, sir, all of you. All of you have to join same time. So we started with postulates. Then we went with the gases, gas laws, ideal gas equation. Then we went with pressure exerted by the gases on the walls of the container. Then we went with kinetic interpretation of temperature. Then we went with law of equipartition of energy. Then specific heat capacity, monoatomic, diatomic, polyatomic. Then we went with last one that is mean free path. Okay. So the meeting will end. Anyways, thank you so much for joining the meeting. Tomorrow morning again, same time, 8 to 10 will be the class. Tomorrow I'll be teaching oscillations. Okay.
Okay. Thank you, sir.
Is it clear?
Thank you,
Yeah.
sir.
Thank you so much. The
Yes, sir.
recording
Yes,
link
sir.
also I
Thank
will
you,
send.
sir.
Okay. Okay. Thank you, sir.
Okay, sir.
Bye.
Thank you,
Thank you,
sir.
sir. Bye, sir.
Thank you, sir.
Bye. Bye. Take care.